Good evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to the Spot On Weather 2022-23 winter forecast. We're moving into part 2 this evening. Here is a familiar picture. If you really like some of the classic Christmas or holiday movies, this is the house there, the main house there of A Christmas Story. So, a little bit of the Hollywood effect there with the snow. But in general, this is one of those classic movies, of course, that we see every year around the holiday season. But in general, let's go ahead and in tonight's video in part 2, I'm going to really dig deeper into La Nina. All right, so the focus in tonight's video, part 2 of the winter forecast, is on La Nina, which we definitely have to consider, being that we're going to see these type of conditions, the La Nina conditions, continuing at least through the early parts of the upcoming winter season. All right, so starting off the La Nina discussion in tonight's video, first things first, we are heading into a triple dip La Nina. 3 consecutive winters with La Nina conditions, and I'll get more in depth on what exactly La Nina is, along with the circulations that set up across the equatorial Pacific. Now, just keep this in mind, there's only been 2 previous winters in which we have seen a La Nina, or a triple dip La Nina rather. There's only been 2 previous winters that we've had La Nina in a triple dip format. Look at the years here, 1973 through 1976 were the 3 consecutive winters in the early to mid 70s, and then the last triple dip La Nina occurring from 1998 to 2001. Now, La Nina winters, they recently have led to at least one snow event for southeastern Virginia. If I bring it closer to the Hampton Road cities, which I occasionally do that in my videos. In general, we have seen some snow for parts of the Mid-Atlantic during La Nina winters. Now, the past 2 winters, we've seen increased snowfall, including last winter's back-to-back weekend accumulating events for southeastern Virginia, specifically the Hampton Road cities. And by the way, and I mention this every year in the winter forecast videos, there are no 2 La Ninas that are exactly alike. Just slight differences really do make those big differences. Just the slightest of differences can make a big or significant difference for sure. So what I did in some of the research in constructing part 2 of this winter forecast for this year is I went back in time to look at the temperatures, the anomalies in degrees Fahrenheit. I'm using the PRISM Climate Group's data set from Oregon State University. I went back to the last triple dip La Nina, and I looked specifically at the third year of La Nina conditions consecutively. So I go back to the winter of 2000-2001. So that was our last triple dip La Nina, the tail end of that. And generally here I'm showing you the temperature anomalies in degrees Fahrenheit. And so on the left here, I'm showing you temperature anomalies for December of 2000. In the middle graphic, I'm showing temperature anomalies. By the way, they're in degrees Fahrenheit. I'm showing you temperature anomalies here in the middle graphic for January of 2001. And then on the far right, I'm showing you the temperature anomalies in degrees Fahrenheit for February 2001. Look what happened here. I just wanted to kind of show you what it looked like as far as temperatures anomalies. Very, very cold start to the winter. In this particular last triple dip La Nina, the winter of 2000-2001, here in December of 2000, look how cold it was, specifically how below normal it was across parts of southern Minnesota, Iowa, northern Missouri, and Illinois. But really, anywhere east of the Rocky Mountains, even all the way down to the Gulf Coast, and even Florida, was below normal in December of 2000. Look at the middle graphic here, a little bit of a rebound across the Midwest in January of 2001. Temperatures weren't nearly as cold, colder than normal, weren't as drastic in January 2001. And actually things kind of flipped there in the northern plain states where temperatures went from very cold in December to above normal, milder than normal across parts of Montana, North Dakota, northern Minnesota. And then still the Gulf Coast and Florida remained unusually cool or below normal even in January 2001. Now by the time we get to February 2001, you'll notice how the eastern United States, basically east of the Mississippi River, generally warmed up into where we had a slightly above normal temperatures. Florida was shivering for December of 2000 and January 2001, and now look, the recovery. Generally running 5 to 10 degrees Fahrenheit above normal in February 2001. But then you notice the return of these below normal anomalies across the northern plain states, eastern Montana, the Dakotas, into Minnesota, and even the western United States got a little bit more colder below normal from parts of Nevada into the higher elevations there of California. So again, here's a summary at the bottom. I want to really take a look at that last triple dip La Nina and kind of see how the temperatures turned out for that particular winter season. And then one more thing before I move on. Yes, this is a limited data sample size. No, I mean, we're only looking at heading into this winter for 2 other previous occurrences, 2 other winters that have had La Nina conditions, triple dip La Nina conditions. So in general, this is a limited data set. So just keep that in mind. Now, what goes on with La Nina? The La Nina weather across the United States is denoted here on the left. And what you see is typically a blocking upper level ridge or high pressure system across the northeastern and eastern Pacific. The polar front jet stream rides up and over that ridge, and then it tends to form more of a downstream trough from the northern plain states into the Ohio Valley and into parts of New England. Anywhere south of this jet stream axis is generally warmer and drier than normal in a La Nina winter. If you look at the overall circulations across the Pacific Ocean, specifically the equatorial areas of the eastern, central, and western Pacific during La Nina, what we typically see is rising air motion over the western Pacific Ocean in the vicinity of southeastern Asia and Indonesia, generally north of Australia. We see the circulation continue to where it's sinking air over the cooler than normal water temperatures across the eastern, equatorial, eastern, and central Pacific. So where there's below normal water temperatures, the air is sinking, and in this case during La Nina, it occurs over the eastern Pacific Ocean. And then when you see these above normal or warmer than normal sea surface temperatures in a La Nina winter, you typically see rising air or vertical air motion, and a lot more in the way of showers and thunderstorms, more tropical convection in parts of Indonesia there during a La Nina season. Rising vertical air motion, again, there's a summary in the western Pacific and also in the western Atlantic, believe it or not. There tends to be a lot more rising vertical air motion in the western Atlantic as well. Now, if I were to look at the conditions across the equatorial areas during a strong La Nina, and I'll get into the differences between a weak, a moderate, and a strong La Nina. Those are the 3 categories of La Nina. The rising and sinking air motion in the tropics really does make a difference in the overall global weather regimes during the winter season. And definitely, when we're talking about the Pacific Ocean, definitely that impacts North America, the United States. But here's just another summary of what's going on. Where you see the blue coloring, that's where we're seeing wetter than normal conditions. And then generally, that wetter than normal conditions, again, is over the tropical areas of the western Pacific Ocean, generally in the vicinity of the equator. And then you get drier than normal conditions over the cooler than normal waters across the equatorial central and eastern Pacific. And the jet stream tends to really orientate itself more west to east and be fairly vigorous across the northern Pacific Ocean. One other thing to mention with a La Nina pattern, it generally tends to trigger a negative Pacific North American pattern, a PNA pattern, which we saw back in December of 2021. When I did the review in the part 1 of the winter weather forecast video, I talked about how mild it was in the eastern United States and how much cooler than normal it was in the west. With a negative Pacific North American pattern or PNA pattern, you typically see a trough and colder than normal temperatures in the western United States, and then a ridge downstream of that over the eastern U.S. where it's milder and drier than normal. So again, the rising and sinking air motion in the tropical areas, specifically in the Pacific, really do make a difference for our weather in the United States during the winter season. So what is the forecast for this upcoming winter? La Nina is generally favored. It's going to be favored for the 2022-23 early winter season. There's a 91% probability by the NOAA Climate Prediction Center. This overall probability decreases to about 54% as we get into January through March of 2023. So still slightly more than 50%. And I'll show you the bar graphs here in a moment and the models, the climate models. What is La Nina in general? Just a review. It is defined by negative oceanic Nino index, ONI, less than or equal to minus 0.5 degrees Celsius. The Climate Prediction Center, this is their classification for La Nina conditions. They occur when monthly the Nino 3.4, and I do have that here in the bottom right showing you this is the Nino 3.4 region across the equatorial, eastern into the central Pacific Ocean. When these particular temperatures in this Nino 3.4 region meet or exceed minus 0.5 degrees Celsius or even cooler than that from climatological norms, cooler than normal, along with consistent atmospheric features, that classifies as a La Nina. Now this must be forecast to persist for 3 consecutive months. Now let me go back. When I say this term right here, with consistent atmospheric features, what I'm referring to is this, okay? Where we're seeing an abundance of convection, tropical convection across the western Pacific Ocean, Indonesia area, and where we're having sinking air motion over the eastern equatorial Pacific. Okay, so this is what we mean by that when we say consistent with these atmospheric features. All right, so now let's take a look at some of the data put out by the NOAA Climate Prediction Center, generally showing these are the models on the far left. Now this is the CFS, Climate Forecast System, version 2, V2. This is the forecast Nino 3.4 sea surface temperature anomalies. And notice the trend in the particular model here. If you look at the black dashed line, that's going to be an average of the forecast ensemble average, or the mean of the forecast ensemble. Generally, we're starting out, and you can see the months are here on the very bottom. And so right now we're about to enter the month of October. Right now our the forecast from CFSV2 is for about a 1 degree Celsius below normal departure there in the Nino 3.4 region. And things kind of remain status quo right on through the early part of 2023, the very early part of 2023 as we get into January. But then you notice this line starting to come back up towards zero. Now, when you're situated between minus 0.5 and positive 0.5 degrees Celsius in the Nino 3.4 region as far as anomalies go, that is considered ENSO neutral conditions. So by the time we get definitely into February, March, and April next year in 2023, we are definitely into that range of ENSO neutral conditions. We look at the bar graphs here on the right. This is the early September CPC official probabilistic ENSO forecast. Blue bars indicate La Nina. The gray bars indicate neutral, ENSO neutral conditions, and then the red bars indicate El Nino. Now, we haven't seen those red bars in El Nino for a few years now. Like I said, we're going into it's a triple dip La Nina. But here are the months, and they're basically divided into 3-month segments. So if we look at September, October, November, we have a 90% probability of La Nina conditions continuing. We get to October, November, December, which we're about to enter October, slightly less than 90% probability of La Nina continuing. And then you notice how these blue bars, these vertical bars, get shorter and shorter, which decreases the probability that we'll continue to see La Nina conditions. But if you notice, all the way generally through November, December, and January, it's looking really probable that La Nina conditions will be persistent. And you see it's down to 80% probability by that point. But then look at this. By the time we get to February, March, and April, now the gray bar is the tallest. That gray bar is ENSO neutral conditions, and notice how it's just above a 50% probability, whereas La Nina has now dropped to about a 38% probability. And then that gray bar continuously gets taller as we head into next spring, 2023. So we're looking at La Nina to continue right on in through the early part of the winter season. Now let's take a look at a comparison in that Nino 3.4 region. These graphics courtesy of Tropical Tidbits. In general, this is last year's Nino 3.4 region temperatures, and this is this September this year. So note, last year we were sitting at a value generally in mid-September of minus 0.32 degrees Celsius below normal in the Nino 3.4 region for those water temps. And now look at this September. La Nina is stronger, it's more firmly established in 2022. This is around the same time period, mid-September of this year. And it was down at this point around minus 0.97 degrees Celsius. And so we have a stronger signature of La Nina at this point in time this year as compared to last year. Look at the La Nina history. I'm taking this back to 2010. This is officially from the NOAA Climate Prediction Center. Anywhere you see the blue boxes, that indicates La Nina. Anytime you see the maroon or the red coloring, that indicates El Nino. And whenever you see these gray boxes, that generally denotes ENSO neutral conditions. So you can see here in the winter of 2010 how we were experiencing a El Nino all the way from December of 2009 right on through April of 2010. And notice how that flipped the following winter as we went into the winter of 2010, especially in early 2011. La Nina came back and replaced El Nino. And then, after that La Nina period for a couple years, we got to neutral conditions. Then we experienced another El Nino in 2014-15, as well as the 2015-16 winters, which, by the way, I remember that December 2015 period. It was ridiculously warm, I'm telling you. Back-to-back 80-degree record high days here in southeastern Virginia in December, really Christmas Eve and then Christmas Day. It was really phenomenal. But look how strong the El Nino was then. We saw sea surface temperature anomalies on the order of 2.6 degrees Celsius above normal in that Nino 3.4 region. So during this strong El Nino winter, it was just really, really a warm winter overall. And then we had La Nina come back 2016, late 2016, then also 2017 and 2018 La Nina. And then we went to a brief period of El Nino between 2018 and 19 winter. And then we went back to La Nina, which, like I said, we're going to be going into the third consecutive winter with La Nina conditions. So you see how La Nina made its presence felt in July of 2020. And, outside of a couple months where the criteria slipped in 2021, a couple periods, outside of these two gray boxes, we've been in La Nina pretty firmly. Now, I wanted to note that some of the biggest snowstorms in Hampton Roads, Virginia, surprisingly have occurred during La Nina winters. And some of the main storms I can think of include the December 2010 storm, in which Virginia Beach, for example, got 14.2 inches of snow, one of the biggest snowstorms on record in the area. January 2018, Hampton Roads areas got a good 10 to 11 inches of snow. That was quite a storm. And then January 2022, even this previous January, we saw back-to-back snowstorms, back-to-back weekend snowstorms, as I talked about in my last video, where we finished on the order of 10 to 11 inches of snow for the month of January. And this was all during a La Nina. Look at the numbers here. December 2010, what were we doing in December 2010? Generally, we're over here in this side of the graphic, minus 1.6 degree anomalies, La Nina. And then January 2018, just about 0.9 degrees Celsius below normal, water temperatures in Nino 3.4 region, and then January 2022, about 1 degree Celsius below normal there in the Nino 3.4 region. These are typical La Nina winters across the United States. This is data courtesy of NOAA, the ERA5 data set. These are the years in which we're taking a sample here, the 500 millibar geopotential height anomalies. And this compares that anomaly to the 1991 and 2020 climatology data set. But in general, what we have is this expansive upper-level ridge that just dominates the eastern Pacific, extends slightly north into the Gulf of Alaska during a La Nina winter. And then you see more of the troughing and the coolest temperatures, the lower height anomalies, generally extending from Alaska down into Canada. So the jet stream kind of just sets itself up between these extremely high heights and these extremely low heights. The jet stream is going to run right between these two areas. And so we generally have a ridge across the eastern Pacific, troughing across the northern plains into the Midwest during a La Nina, typical La Nina winter. You'll also notice some very low, below normal heights across parts of Western Europe during La Nina, specifically Spain. Down here at the graphics here at the bottom left of the slide, showing you United States precipitation for the period December through February during La Nina winters. Generally, it's wetter than normal across parts of the northern plains, Montana, North Dakota, and Idaho. Pacific Northwest is wetter than normal, including parts of the Ohio Valley, Kentucky, into parts of Ohio and Indiana, above normal. Drier than normal conditions across the southern U.S., New Mexico, Texas, Louisiana, right on down along the Gulf Coast, Mississippi, Alabama, Georgia, up into the southeastern United States, the Carolinas. And then on the right here, I'm showing the December, January, February temperature anomalies during La Nina winters. In general, we see above normal temperatures across the southern U.S. as well as up into the mid-Atlantic. And then we do see colder than normal temperatures across the northern plains and the far northern reaches of New England. One thing I want to mention, though, is what type of weather we see. Now, this is just the average, what we'd expect. But it really depends on the strength of La Nina, whether it's a weak, a moderate, or a strong classification. Here is the classifications, okay? So if we have a weak La Nina, that means the water temperatures in Nino 3.4 region are 0.5 degrees Celsius or colder below normal. If it's a moderate La Nina, those water temperatures in the Nino 3.4 region are 1 degrees Celsius to 1.4 degrees Celsius below normal. And then if it's a strong La Nina, we see water temperatures in Nino 3.4 region 1.5 degrees Celsius below normal or colder, even more than that. So stronger La Nina episodes really do lead to drier, mild winters across the mid-Atlantic. The stronger is, the greater the case that we're going to see this type of behavior. Weak La Nina episodes, on the other hand, it's kind of like a wild card. They lead to near average temperatures of precip. In some cases, as I mentioned previously, they can lead to snow events across the mid-Atlantic. And in addition, weaker La Ninas, temperatures, you can have some pretty cold periods during the winter season with a weak La Nina. And now I'm going to break down the weak versus the moderate and the strong La Ninas. I'm going to look at the temperatures. By the way, I'm not going to include any of the precipitation maps here for a weak, moderate, and strong La Nina. And the reason is because in all three cases, it's generally drier than normal across the southern U.S., southeast, up into parts of the mid-Atlantic, and it's wetter than normal across the northern plains, down into the Ohio Valley and the Pacific Northwest. So I really, since there really wasn't much difference in looking at the precipitation maps, the departures from normal, and a weak and a moderate and a strong La Nina, I really just focused on the temperature aspect of it. I really wanted to show you that. And of course, temperature is very important as far as precipitation type that many parts of the United States see during a winter. So the first thing is a weak La Nina. Now notice, again, as I mentioned on the previous slide, how anything that's white is generally near normal as far as temperatures go. But remember I mentioned that in the previous slide, how if it's a weak La Nina, where we're going to have water temperatures 0.5 degrees Celsius to 0.9 degrees Celsius below normal. Water temperatures in that Nino 3.4 region are 0.5 to 0.9 degrees Celsius below normal. Look what happens with the temperatures. I mean, look at that. Near normal for a good chunk of the eastern U.S. They are below normal across parts of the upper Midwest, northern plains, into parts of Montana, Idaho, and Pacific Northwest during a weak La Nina. But again, all bets are off here. If you look at the panels here on the right, these are the years in which we saw weak La Nina conditions. There was really only one winter, I would say, out of all this data set. If you want to consider it two, we can consider two winters. 2005, 2006, it was exceptionally warm across the United States as a whole. And then look at 2016-17 here on the right, how much above normal it was across parts of the southern U.S., all the way up to the Midwest, all the way to the Canadian border. I mean, the icebox of America, the city known as International Falls, Minnesota, was also well above normal that winter. The only cool spot in 2016-17 winter was in the Pacific Northwest. But a weak La Nina, check it out. I mean, we even had a period in 1983-84, which was an extremely cold winter across the eastern U.S. That was a weak La Nina winter. That did not. If you look at this graphic here, the green and the blues, that's well below normal temperatures for that winter. And it's supposed to look like this, right? So again, no two La Niñas are ever exactly alike. Let's move on to moderate La Niña temperature trends. With a moderate La Niña, notice generally how the same area as weak is colder than normal again, denoted by the legend here at the bottom. And the green areas are below normal temperatures. But even a moderate La Niña, we take the average of all the moderate La Niñas, generally fairly near normal across much of the United States, believe it or not. Here are the winters that feature moderate La Niñas. The only real hot winter was 2011, 2012, very much above normal across a large chunk of the U.S., from the Rockies to the East Coast and up to New England, down the Gulf Coast. Everywhere was pretty warm in the winter of 2011, 2012. And then you have a much below normal situation in moderate La Niñas with 1970-71 winter as well as a 1995-96 winter. So, again, just wanted to share this information with you. Strong La Niñas, on the other hand, look at the signature difference here. Yellow indicating above normal temperatures in the order of 2 to 3 degrees Fahrenheit here. All this, Texas, Oklahoma, into the Tennessee River Valley, southeastern U.S., all the way up to the Mason-Dixon line, as well as cooler than normal temps along the U.S. West Coast. And here is some sample winter panels here on a strong La Niña. Look how warm the winter of 1990-2000 was. This data set I showed you was from the last year. The triple dip La Niña was 2000-2001, earlier. But that middle winter, the triple dip La Niña, was very warm. Wow. And then 2010-2011, this was a strong La Niña winter, and yet the temperatures were below normal for much of the winter from the northern plains right on down to the East Coast. And then finally tonight in the video, I wanted to leave off with showing snowfall during La Niña winters. In general, just focus on snowfall. Here's across the whole U.S., and you'll notice that we tend to see above normal snowfall across Alaska, right on down the western parts of Canada into the Pacific Northwest, as well as across the upper Midwest, tends to see above normal snow right across to New England. The brown color indicates below normal snow, so across the Mid-Atlantic, typically see below normal snow in a La Niña winter, as well as parts here of the southern plains and even parts of western Nebraska. But be mindful, and this is really what throws things off. This is what makes seasonal forecasting, specifically the winter, so challenging, is there are other teleconnections out there, or climate drivers, that can be way more dominant and override the effects of La Niña. I'm going to get into this much more in-depth in part 3 of this winter forecast video series. I'm going to talk strictly about teleconnections. Everything outside of La Niña I'm going to talk about in part 3 of the series. But I do want to mention again that the stronger the La Niña is, the greater its influence is going to be on U.S. weather. Overall, if I bring it closer back to southeastern Virginia again, below average snowfall is expected in a La Niña winter, but some of the biggest snowstorms, believe it or not, for the Hampton Roads, Virginia cities have actually occurred during La Niña winters, including that mammoth snowstorm of 2010-2011 in late December. I mentioned that Virginia Beach recorded 14.2 inches of snow in just that one storm. But look at the whole winter season, the 2010-2011 winter season. We saw 21.8 inches of snow recorded at the Norfolk Airport. Just crazy. 1999 to 2000, another 9.1 inches had occurred during the La Niña winter. And then the 07-08 winter we only saw 0.2 of an inch of snow. And the 2011-2012 winter, we only saw half an inch of snow for the entire winter. During the 2020-21 season, we saw 3.4 inches. So I'm going to go back here to, I think I have this one, 2007-2008. Yep, it was a strong La Niña. And you can see it was, again, much above normal across the Mid-Atlantic. So that makes a lot of sense when I look at this number being so low in that particular winter, during the La Niña winter. All right, that wraps the video up tonight. I've got a lot more to cover in the winter outlook. I appreciate the very nice comments I've seen on the YouTube channel from some of my past video in particular. I try to broaden the scope of my videos out to just more than southeastern Virginia, but I do tend to focus and zone in on southeastern Virginia in particular for the Mid-Atlantic. But in general, it's always interesting to look at the trends nationwide to find out what's happening, or even expand that outlook well out into the Pacific Ocean. We talked at the beginning of the video about the importance of this whole global circulation where air's rising and where air's sinking. And it's very meaningful as far as setting up the whole long wave or jet stream pattern during the winter season. So definitely important to take a look at convection. Where's the convection occurring in the Western Pacific? That also ties in with what's known as the Madden-Julian oscillation, which I am going to get into in the next video. I'm going to talk about everything from the AO, NAO, MJO, AMO, and much more in the next video. So I'm looking forward to it. I have it ready to roll. So hopefully I'll get that in part 3 out soon. Right now I got winds really, really strong outside spot on weather this evening as we are feeling some of the remnants of Hurricane Ian. Ian made landfall today into Georgetown, South Carolina as a Category 1 hurricane. And now it is just, it's just really, really windy out there this evening. All right, that wraps things up tonight. Spot on Weather. I appreciate your subscription and you taking time, most importantly, out of your schedule and your lives. I certainly wish the best for everybody. I certainly hope and sending prayers out for everybody down in the Fort Myers, Florida area after Ian went through there. A very intense hurricane, obviously. And it's been all over the news, of course. And so prayers to those folks down there. That's all I got for right now. And my intention, I'm really focusing deeply on the winter outlook this year. I'm looking at all the factors, and I'm working my way through the video series. Okay, that wraps things up for now. Everybody, take care, and God bless.